given that f of x equals this piecewise function, we have 2x minus 1 for values of x that are greater than 0, and x squared plus 2x plus 7 for values of x that are less than 0. We want to determine if the function is differentiable at 0. Okay, so a couple things we can do here. We can try to draw this graph out, right? First thing you should probably do is just plug in f of 0, right? So when it means differentiable at 0, okay, it means that maybe the limits from both sides have to be the same, but also it should be continuous at 0 as well. Okay, so let's determine that, right? Let's plug into 0 here, okay? Like I said, if you want to graph this, you can, but if I plug into 0 here, right? 0 at this point for this piece of the function, right? So f of 0 for the top piece will be -1. F of 0 for the bottom piece, though, right? We notice what is it equals 7. What does that mean? Okay, it means that graphically, these points, okay, do not even touch. Okay, so 2x minus 1 is just a line, right? And then -1, we have a line that goes up like this. Okay, x squared plus 2x plus 7, that's a quadratic function. Okay? Looks a little something like this, I guess. A little bit U-shaped right here, right? So we see that the limit from the left is actually 7, right? The limit from the right is -1. It's not even continuous at 0. Okay, so we can determine that no, unfortunately, this function is not differentiable at 0, right? So this would be a no. Now, actually, if you do find the limit, right? If you find the limit, remember this is a piecewise function, okay? So we don't have to find the limits, right? We plug in the values, okay? We determine that the limits are different, so it's not continuous, which means that it's not differentiable.